Is it the gas valve? Is it the control board? How do you troubleshoot a gas valve and a control board? How do you know if the valve's bad or the control board's bad? You're watching HVAC Tips for Technicians. I'm Tad. This is Taddy Digest. Let's go. We're working on a packaged gas unit. This is the gas section right here. Here's our gas valve. Here's our control board. This is actually a callback. I was here last week, replaced the thermostat wire, tested the heating, there was nothing wrong. Tested the cooling, there was nothing wrong. So I got a call back today. The first thing I noticed is that we are sparking, but then there's no flame. There's a diagnostic light here, an LED on the control board. You'll see right there. It is solid right now, but it was flashing one time. And what does that mean? Diagnostic, flash once, failed to detect or sustain flame. Now, to work on a piece of equipment like this, we got to know the sequence of operations. Let me show you what it's doing. I'm going to give it a call for heat by connecting the R and the W. The first thing that should happen is the inducer motor comes on. Then there's a tube connected to the housing which goes to the pressure switch. The pressure switch should close. After all the safeties are closed, like the limit switches and the rollout switch, it should spark. Now it's sparking, but it's not lighting the burners. So there's the spark igniter. It should light. The carryover track carries it to the other side of the burners, and then we got a flame sensor that keeps it lit, right? Through flame rectification. But as you can see, we don't have a flame. So that's the reason we had an LED flash of 1. It's sparking, but there's no flame. Whenever we get an igniter that starts sparking, we should have a signal sent from our plug here for our control board, and that 24 volt signal should be sent to this gas valve. So whenever we get 24 volts to the coil energizes, valve should open. And if we have gas, then we should have flame. If the control board is bad, then it's probably not sending a signal to the gas valve, right? If we have input to the board but there's no output, that could be an indication that board is bad or faulty. But we need to check gas pressure first, because I think that's probably the easiest, and then voltage to the valve. So let's go ahead and check gas pressure on the inlet side, because if we don't have gas coming in, we won't have gas going out. We're going to take our Allen tool. This is the 3 32 size, so 3/32. We're going to loosen up the inlet screw. You want to shut the gas off when you do this, because you don't want gas just piling out of that port. Me, I left it on. I'm a professional. I'm going to get that tube on there quick enough. We're not going to have an issue. So what do we got? Our manometer is reading 9. So if we've got 9 coming in, we should have 3.5 coming out, right? So we got gas going to our valve. We know that's not an issue. And by process of elimination, we're able to figure out what the issue is, because we're just going from one check to the next check. So now that we know gas valve has gas coming in, we're going to go ahead and take out the outlet screw now. Now you don't have to shut the gas off going to the gas valve when you're taking the outlet screw out, unless you have the unit running. Just unplug the disconnect, or take the call away, or turn the thermostat off. So outlet screw is loose. I don't have to take the outlet screw all the way out to read pressure. Now we've got our manometer tube connected, and I'm going to go ahead and zero it out. All right, zeroed out. We're going to go ahead and take and connect R and W. Gas valve is on, inlet screws tightening back up. R and W, here we go. Gave it a call for heat, but it's not coming on because it's locked out again. See the code? 1 flash. Now let's go ahead and unplug or disconnect the R going to the board. And then, oh wait, that's not gonna work. Oh wait, that did work, okay. All right, now we're calling. Now that it's sparking, we should have power to the gas valve, but looks like we have no pressure. So what are we going to do next? We're going to take the wires off of the valve and I'm going to check voltage. Take my meter dial, put it on volts AC, take the leads, put them in the female spades that went to the valve's coil. Let's see what we get. Looks like we're not getting enough voltage. No 24 volts, just 15, and then no outlet pressure, so 0 on the outlet. Now we're going to take power straight to the valve. So we're going to bypass that control board. I'm going to show you what I'm doing. I've got a wire connected to the C wire, and I've got a wire connected to the R wire. This is going to provide 24 volts straight to the valve with these spades. So I've got the other wires disconnected. Make sure the power's off when you do this, and make sure you do not leave power on this valve. This can be very dangerous if you don't know what you're doing. Now let's turn on the manometer and let's see if the valve opens. Here we go. Oh, 4 inches of water column, so yeah. So the valve's fine. We provided it with voltage and it opens. So if we provided it with voltage but it didn't open, then we have an issue with the valve, but we don't. We have an issue with our control board. We know that. We're getting the input to the board. We're getting the R to C. We're getting the 24 volts. We've got the 240 volts, so we know how to check that. That's pretty simple, but we don't have power going to our valve. Also, may want to check all your safeties. You want to check across your limit switch, across your rollout switch, across your pressure switch. But all that is closed. Otherwise, we wouldn't have a spark, because that's what happens after all of our safeties close, after our pressure switch closes. So now we know what we have to do. We have to replace the control board. So I'm going to give you some tips for doing that. I'm going to get that replaced and then we're going to recheck. Replacing the board is super simple. Basically just take the screws out first. This is what I do. Now this is my method. I like it this way, that way I don't have a wire on a wrong terminal. So I get the new board, put it up here like this. I go ahead and screw it back in like this, and make sure that you have proper amount of screws in place. You may need to have an extension. I'll put the other screw in a minute, but I just want to show you what I do. So I just take off one wire at a time and place it on the new board like that, okay? Super simple. You're just doing wire from wire. Wanted to give you that tip. Now we've given it a call for heat again, connecting R to W. Instead of taking these wires off where the valve wouldn't have power, I'm checking up here on the plug. What do we got? We got 4 inches of water column, and we've got 26 volts going to the valve. Now I'm going to show you how to adjust the gas pressure, super simple, and then I'm going to show you where I found those wires on that board and how I read the schematic. So I'm going to take the adjustment screw out. And there's the cap for the adjustment screw. And then I'm going to lower the pressure by going counterclockwise. And it looks like we need about 3.5. And there it is, 3.5 inches, so it's set properly. Now I'm going to turn the valve off, take my tube off, and re-screw in that outlet screw. We don't want to leave that out. Let's find the control board, the gas valve, and our plug. This is a rectangle and it says IFC, Integrated Furnace Control. There's our plug, PL1. There's a line in between this plug on the board and these set of numbers. These are the 9 pins for that plug. There's the igniter, that circle. Over here we got the GV. This is the gas valve. There is a BR, a brown, and a BL, a blue wire that go to the number 2 and 3 on the plug. Let's find that on the plug. Here's the plug for the control board. You can see it says P1 right here. And then if you look around the plug, it's labeled, each wire. So it's got a 1 here, it's got a 2 here, a 3 here, a 9 here, a 6 here. So if we look at the 1, 2, 3, our wires should land right here, 2 and 3. So if we look, we should have a brown and a blue wire. Look, blue and brown. So these are where my leads were. We got it fixed. The control board was the issue, and now the customers got heat. I was here last week, so this is a callback. I did explain to her that I really feel like that the thermostat wire issue could have caused the control board issue. There's always cause and effect. If we go to a call and we replace the bad capacitor, which was the effect, then, and we never take care of the cause, which is the dirty coil, then we're probably gonna have to come back and replace another component. Always make sure that you tell the customer if you think there could be another problem down the road, that you go ahead and tell them that. For this, I had no idea we're gonna be back to replace the control board. Let me know in the comments what you think about the thermostat wire being connected to the bad control board, or if you've had that issue in the past, or you're having the issue now. Let me know if you guys need help. If you got questions, remember, questions can lead to new content. So put your questions down below. I hope you enjoyed this video, and I hope that you learned something. I hope that now you know how to tell the difference between a bad gas valve and a bad control board, that you know more about the sequence of operations and how to process and eliminate, because those two things, learning them is going to help you to be able to find the answer quicker in the field, and that's what I want for you. If you like this video, hit the like button, subscribe, and smash that bell, ding, so you know what I'm doing. You've been watching HVAC Tips for Technicians. I'm Tad, this was Taddy Digest, and I'll keep you cool if you let me.